This lesson is section 8.6, sine and cosine ratios. Complete the two problems from the warm-up. Pause the video. When you're finished, check your answers. Number 1, find BD if it's the altitude of an isosceles triangle ABC where AC is 6 and the measure of angle A is 50 degrees. Because BD is the altitude, it is perpendicular to the base and it bisects the base, so AD is congruent to DC. So to do your calculation, you have tangent of 50 is x over 3. Well, where do these values come from? So you have AC being 6, so we have the bisection of the base, so we're going to have 3. Both of these values here, as well as segment DC. And then we also have this 50-degree angle for angle A. So you can see that in order to find the altitude, if you want to call that x, you can see that it's a tangent relationship. So the tangent of 50 is x over 3. You're going to cross multiply, so x is going to be 3 tan 50, or 3.58. Once again, make sure that your calculator is in the mode that is degree. Number 2, find y to the nearest hundredth. So you'll notice that you have a relationship occurring of 1 on a leg, 2n here, and n radical 5. But if you get rid of all of the values of n, you'll be able to see the ratios are just a 1, a 2, and a radical 5. Even so, you can calculate using tangent relationships. So the tangent of y is n over 2n, but the n's cancel out. So I'm left with 1 over 2n. So the tangent of y is 1/2. To solve for y, we're going to multiply both sides by tan inverse. So we have tan inverse of 1/2, which is 26.57 degrees. Besides tangent, we have other trigonometric ratios that we can work with. There's 2 others. We're going to study sine and cosine. So if we're looking at angle A in terms of tangent is BC over AC, opposite over adjacent. Sine and cosine have their own relationships as well. The sine of angle A is going to be the opposite over the hypotenuse, BC over BA. So sine is the opposite side over the hypotenuse. The cosine ratio also involves the hypotenuse. For cosine of angle A, it's the adjacent side, which is this dark blue side over the hypotenuse. So this is just a recap of the 3 relationships as well as the ratios. An important mnemonic to remember, or a way to memorize the sine, cosine, and tangent relationships is SO, CA, TOA. S, or sine, is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And TOA, tangent, is opposite over adjacent. SO, CA, TOA, or SOHCAHTOA. Now, when I was younger, we learned it as the relationship of thinking about it as an Indian chief, SOHCAHTOA, with all of these words listed. Another way you can think about it is somebody standing and soaking their toe. Hey, SOHCAHTOA. Either way, you can use this idea to memorize the ratios. Let's do some calculations. If you're given the length of a hypotenuse or need to find the length, use sine or cosine. The hypotenuse always goes in the denominator. So if I'm trying to find an unknown side, I always start with the angle relationship. This is the 72 degree and dealing with the opposite over the hypotenuse. That is sine. So the sine of 72 is going to be the opposite, which is x over 18. Multiply both sides by 18, and you get 17.12. Number 2 is an example of cosine, or ca. If you look at the angle of 15 degrees, the cosine of 15 is the adjacent side, which is x, divided by the hypotenuse, which is 12. So cosine 15 equals x over 12. Multiply both sides by 12, and you get 11.59. The third example is the tangent that we've already calculated. And we have tangent of 26 is opposite over adjacent, which is 7 over x. Cross multiply. So don't forget, you can always put a 1 underneath your tangent. There you go. And cross multiply. And then you divide by tan 26, and you get x is 14.35. Okay, it says find the value of x and y in the following triangles. So looking at this first picture, you're going to be calculating a missing leg, which is x, and another missing leg, which is y. But you're given the hypotenuse and the angle of degree. So in both of these cases, you can use sine and cosine because they involve hypotenuse. There are definitely two ways to do whichever value you work out second. But in the beginning, you are going to have to use a tangent, or sorry, a sine or cosine relationship. So let's go ahead and start with that 37-degree angle and do a sine relationship. Sine of 37 is opposite over hypotenuse, which is x over 35. And x is going to be 35 sine 37, which is 21.06. Now that I know the x value, I could use a tangent relationship to find y. I could do tangent of 37 is whatever the value of x was divided by y. Or I could do a cosine relationship and say that the cosine of 37 is y over 35. It does not make a difference. I chose to use cosine here to do the practice for cosine. So multiplying both sides by 35, and you get 27.95. Please pause the video and do number 5 on your own. Okay, solution. The tangent of 50 degrees is going to be the opposite over the adjacent, and you get 89.38. Solving for y, because it is the hypotenuse, I can say that the cosine of 50 is 75 over y. And cross multiplying and dividing, you get 75 over cosine 50, and that's 116.68. One thing we have not discussed is the possibility that you could choose to use Pythagorean theorem. If you know any of the two sides, you can always find the third. So that's another option for the second portion of the workout. But once again, there's a lot of flexibility. You can always use any of the sine, cosines, or tangents based on the information you're given, or Pythagorean theorem. Using the inverse trig functions to find missing angles. Just as there's a tan inverse of x, you can also do sine inverse and cosine inverse. So number 6, we have find angle V. So we have opposite over hypotenuse, which is a case of sine. So we do sine of V equals 22 over 50. To get V by itself, we're going to multiply both sides by sine inverse. Using your calculator, you'll get 26.1. Number 7. To find y in this problem, you'll notice the opposite is not available to calculate unless we did Pythagorean theorem, but we could also do cosine. So the cosine of y is 9 over 14. Cross multiply, and use cosine inverse. So you have 50 degrees. Number 8, find all the missing sides and angles in triangle ABC. Pause the video and choose to do this problem in any way you would like. So find side BC, find angle A, and find angle C. Solution. This is a Pythagorean triple. It's based on a 3, 4, 5 idea, so this is a 15. You could also follow that with Pythagorean theorem if you'd like. So now you're given all three sides. So you can go about finding angle A and angle C using sine, cosine, or tangent inverse. So this one is, I'm going to choose to start with the cosine of angle A. The cosine of angle A is 20 over 25. And A is the cosine inverse of 20 over 25, which is 36.87. Angle C, as we know, angle A plus angle C must equal 90 degrees. We could certainly do 90 minus this value to get 53.13. You could also use one of the trigonometric ratios to figure out angle C if you'd like. Number 9 is a bit more challenging problem. But if you look at this, you don't see any right angles. So we're not able to use trig as it is currently. However, this triangle is unique. You'll notice that the two base angles are V degrees, which means they are congruent. So what that tells me is that this triangle is isosceles. And an isosceles triangle, just like an equilateral, you can draw in an altitude from the vertex that bisects the base and is perpendicular to the base. So these two pieces are congruent, and those are both 8s. There we go. Now furthermore, if you look at one of these right triangles, they have a hypotenuse of 10, and they have a leg of 8. This is also a Pythagorean triple, so that tells me that the altitude that I drew in was a 6. So from here you can go ahead and do some calculations for V and for W. Angle V can be done with any of the trig ratios using 6, 8, or 10. So I've chosen to do cosine. So cosine of V is 8 over 10. Cosine inverse, and that's 36.87. You'll notice that it was not necessary to use the height of 6 or the altitude of 6 to do any of the work that I did here, but it is helpful extra information in case you see the problem a different way and want to use the trig for it. So this angle is 36.87. So angle W is going to be the entire triangle minus 2 of the 36.87s. So keep in mind angle W is part of a large triangle that's a total of 180. Subtracting the other two gives me 106.26. Another option would have been to figure out the total between V and half of W, because angle W is bisected in this picture as well, because these are congruent triangles. So you could certainly calculate half of W and then choose to double it. Okay, number 10. A 6-meter ladder reaches up high upon a wall. When placed at a 70-degree angle, and then when placed at a 60-degree angle, how much higher to the nearest tenth of a meter? So we have a couple things occurring here. We have the original height, or actually, sorry, this is the second height when you create a 70-degree angle. We also have the height that's created from the 60-degree angle. And the question is asking how much higher is the x height compared to the y height, or how much taller is the ladder when it's placed at 70 degrees versus 60. In other words, how much higher is it up on the wall? So this difference is this letter z. But in all of these cases, these are perpendicular relationships anyway. So you're going to calculate x using a 70-degree angle, y using a 60-degree angle, and then figure out the difference. But they do tell you that the ladder is 6 meters tall. No matter where you angle that ladder, it's going to remain a hypotenuse or a height of 6, whether it's the red line or the blue. So to start this problem, let's look at the relationship in the 70-degree right triangle. So if I move this over and place it into the right triangle position, if I use the 6 as the hypotenuse, I can see that the x value, or the height that the ladder is up against the wall, is a sine relationship. The sine of 70 is x over 6. Multiplying both sides by 6, you get 5.64 meters. In other words, when the ladder is placed at a 70-degree angle, the top of the ladder is 5.64 meters from the top. Now we're going to do another calculation using the 60-degree angle, and it's going to have a hypotenuse of 6 as well. So we have the sine of 60 is y over 6, and that gives me 5.20 meters. So in other words, at a 60-degree angle, the height where the ladder touches the wall, the top of the ladder is at 5.2 meters. So z, which is the difference between those two, can be calculated simply by taking 5.64 minus 5.20, giving me 0.44 meters higher. This is the end of 8.6, sine and cosine ratios.